Hello and welcome to my second YouTube video. It's still from the project of the 4-digit code lock. And today we'll be looking at the binary counter. But first I'm going to explain a little bit why I got building on this project. I had one of these rotary telephone dials lying around. It's all mechanical. This one's already quite a new one. It's one of the last ones they made from rotary dials. So it's not very attractive, but I like the mechanical aspect of it. So I thought, hey, I should program a little microcontroller to monitor the pulse trains and convert it into digital information and do stuff with it. Yeah, but then I got thinking, I have a whole bunch of these little blue relays lying around from a telecommunications board, these guys. Little 12-volt relays, double pole, double throw. I desoldered them off an old board. So I thought, why not do it with relay logic? So yeah, that's how I got started on this project. So I made this little thing, which is a 4-digit binary counter. Each segment is a D-type flip-flop with the output feeding back into the input. It divides the clock pulses by 2 on each stage. So I cobbled this together. This one I've actually dropped quite a few times, so it's all mangled up. But it worked. There's these little LEDs in between where you can see the binary value of the number you dialed. Yeah, it was working fine. So then I thought, hey, why not, store the information into 4 separate registers and do something with that data so I can remember 4 digits. So that's when I decided to get more little relays and cobble this thing together, which is a transparent latch, a 4-bit transparent latch. Yeah, so that was fun and working, and then I thought, hey, why not connect them to Nixie tubes? I have these Nixie tubes lying around. Not sure which one this is. Might be the 18. So I made this extra little circuit, which is basically a binary to decimal decoder, and I got the Nixie tubes working. So yeah, it just grew bigger and bigger from there. So I had to actually order more little relays to continue on with this project. Yeah, so it all started with this little thing and the rotary dial. Yeah, as I progressed, this project took up more and more space and became bigger and bigger. And I really like these Nixie tubes. And I did a real fine solder job with these tiny wires, and it looks nice and clean, and it's double layered. I'm not sure if you can see it. They're all floating above each other, and I really like the way this looked. And then yeah, this one was driving it, and I wasn't so happy with the way this one looked. Too much plastic and big ugly solder joints, and so I thought, hey, why not rebuild this one? This was actually the second version I made of the latch, of the memory latch. So yeah, so I created a new version, which is right here. It looks a lot more tidy and neat, a lot cleaner. Also the LEDs in the old version, they were very bright and sharp, and I didn't really like it. It was too distracting. So I printed these little 3D printed things which I can stick the LEDs into from the back to dim and diffuse the light a little bit, and it looks so much better now. So yeah, the quality looks nicer as well, not as much plastic, not that much chaos as in this one. So I'm really digging these guys, so I thought, well, if I change that one, I can't leave the counter like this. Again, a lot of plastic covered wires and not so straight diodes and resistors, and I don't like the big capacitors on top, and it's not very organized. So I decided to rebuild this one as well, which gives me an opportunity today for me to show how I go about making the new one, and I'll also go into the schematic of the counter and explain how it all works, and hopefully at some point I'll have all neat looking bits of relay logic that I will be connecting together with copper wires and a bus system, and yeah. Okay, so let's have a look at the schematic. Before we look at the schematic, might be interesting to have a look at one of these rotary dials. This is an older version than the other one that I showed you. As you can see, it's very mechanical. It's lovely big contacts and springs, and yeah. So I'll give it a whirl from the bottom. There you go. Hope you can see this. So there's a few things you can take notice of. Let's see if I can focus on that. Yeah, there we go. This is actually a speed controller. It's got these two little weights inside, and as it spins faster and faster, they move outwards, centrifugal force, and they hit this little drum brake, and they slow the rotation down, so it returns at a nice slow pace. You can have a look at that. And what else is going on here? You have this little contact here, which is operated by this little oval shaped disc, which generates the pulses. If you dial a 1, it only generates 1 pulse. You dial 9, it generates 9 pulses. It's difficult to count 0 pulses, so the 0 on the dial actually generates 10 pulses, which comes in handy in the rest of the circuitry as well, that we don't have to deal with 0 pulses. This little switch is activated as soon as you start moving the dial, and it'll close as soon as you start moving the dial, and it'll open once the whole digit is finished dialing, which is important because this switch will actually trigger the latches later on. But yeah, you can have a look close up. We'll see if we can focus on this and give it a whirl. No idea what digit I'm dialing. Oh, I love the action of this little thing. So this is where the pulse train is generated. All right. Yeah, I have different models as well. This one is also a nice looking one. The back is different. It's somewhere in between the other two, generation wise, because this already has a plastic disc with tabs generating the count pulses using this little spring lever attached to the knobs. This is the same contact that still remains closed for the duration of the dialing. And again, this little brake thing to make sure it's rotating at a nice constant speed.